5 ways AutoForm makes tool design more efficient for sheet metal parts. When 2D CAD systems were introduced in the late 1980s, drawing boards everywhere became obsolete. In the 1990s, 2D drawing systems became 3D, and those who utilized 3D solid modeling correctly could generate 2D views and details automatically. Today, designers of sheet metal tooling need never draw in 2D again, since all 2D views and details are generated from the 3D model by advanced CAD software systems. It would be considered very inefficient to design a tooling project in 2D. A similar, but less accepted, shift has already occurred in the world of sheet metal forming simulation. Advanced AutoForm software features allow engineers to design sheet metal tooling processes in 3D without an advanced CAD system. In fact, 3D CAD modeling of tooling is the last step of an efficient sheet metal forming simulation. When sheet metal forming simulation was first introduced, it was thought that the entire tool had to be designed in 3D CAD as the first step, before a simulation could take place. Furthermore, for progressive type tooling, the first step was always to create a full 3D strip model, complete with blank, carrier and stretch web details before any confirmation of a successful forming process. Here's how AutoForm turns this inefficient thought process on its head, and puts 3D design into the incremental simulation process. 1. Only the final 3D product geometry is imported into AutoForm. All tooling shape and process steps are designed using advanced AutoForm Die Designer software module, working backwards from final form to first draw and every step in between. 2. AutoForm Die Designer functions are parametric and hold logical relationships with the model, but without the restrictions often found in CAD systems. A whole new approach to 3D modeling is created inside AutoForm without touching CAD, and improves efficiency many times compared to importing tooling surfaces created in CAD. Needless to say, the geometry created inside AutoForm Die Designer is ready for simulation instantly and linked directly to the simulation setup. 3. AutoForm Trimline Optimization determines the correct blank shape and size using iterative simulations. Stretch webs, blank size, pitch and traditional details are ignored initially for investigative simulations. These details are not finalized until a full working simulated forming process is completed. Traditional designers manually calculate, or guess, the correct blank shape or stretch web and pitch, only to find out in simulation their idea was not successful, and must consume large amounts of time redesigning in CAD. AutoForm users do this in simulation, without any CAD software. 4. AutoForm allows infinite definition and evaluation of alternative tooling geometry, by simulating over and over again, adjusting geometry many times based on simulation results. The trial and error is not only done in simulation, it's done without an external CAD system. Designs are safe only when AutoForm shows no problem areas, and confirmed by a human. 5. The last step in an efficient AutoForm tool design is to export the geometry from the simulation. AutoForm R7 creates CAD surfaces on the fly based on the mesh used in the incremental simulation. Draws, preforms, developed blanks, stretch webs, carriers, etc., can all be exported and then imported to any CAD system to create the final tooling shapes that have already been proven in simulation. We call the above 5 steps simulate complete. What used to take days and weeks of switching between CAD and simulation, now takes just hours. In a recent benchmark study, we found a pure CAD-based approach to simulation took a full 2 weeks to obtain a less than optimized result. When stamping simulation approached the same part using Simulate Complete, a better result was achieved in just 8 hours.